Hello guys, today we are going to be looking at the mole concept. So in this video, we are going to look at some basic calculations involving the mole. Alright, by definition, a mole of a substance is the amount which contains as many elementary particles when compared to carbon-12. In chemistry, a mole is just a counting unit, just like we have 1,000 representing 12 units or 12 items. A pair of shoes represents 2 shoes, that is the left and the right pair. I hope nobody wears 2 left shoes or 2 right shoes. Alright, that's by the way. Alright, so in chemistry, instead of saying 1,000, we say 1 mole. But it doesn't mean that 1 mole is equal to 12 items in chemistry. Alright, so then what is 1 mole equivalent to in chemistry? 1 mole is made up of 6.02 times 23 particles, which we all know as the Avogadro's constant or number. So 1 mole is made up of 6.02 times 23 particles, and these particles can either be atoms, they can also be molecules, they can be ions, as well as electrons. So let's talk about the Avogadro's number, which is the number of particles in 1 mole of any element. Recall, these particles can be atoms, molecules, ions, or even electrons. So by definition, it then means that provided that the element, ion, electron, or molecule is up to 1 mole, it will contain Avogadro's number or constant, which has a value of 6.02 times 10 raised to the power 23 particles. Okay, let's buttress that point. For example, 1 mole of hydrogen will contain 6.02 times 10 raised to the power 23 particles, even though it weighs 1 gram. Carbon will also contain 6.02 times 10 raised to the power 23 particles, even though it weighs 12 grams. Also, sodium will contain the same number of particles as long as it is up to 1 mole, which is 23 grams. It does not matter the element at all in the periodic table. Provided it is up to 1 mole, it will still contain Avogadro's number. Alright, let's look at relative atomic mass, which is almost an inevitable calculation we will encounter while dealing with mole calculations. So the relative atomic mass is just the average mass of all the atoms of an element compared to carbon-12 isotope. In simple terms, what 1 mole of each element would weigh. I'm sure you've seen calculation questions where you were asked to take the value of some elements in this format. So here we have C as in carbon, which is 12 grams, O as in oxygen, which is weighing 16 grams, and S as in sulfur, which is weighing 32 grams. Also, we have sodium weighing 23 grams. All these are just masses of 1 mole of these elements. And of course, let's not forget the Avogadro's number, which was given there to 6.02 times 10 raised to the power 23. Alright, whenever this 6.02 times 10 raised to the power 23 atoms or particles, whatever, shows up, just know that you are going to be doing a calculation with the number of particles. Alright, let's solve a simple one here. We are asked to calculate the mass of 2 moles of carbon, and we are asked to take C, which is carbon, to be 12 grams. So normally, 1 mole of carbon weighs 12 grams. So what would 2 moles weigh? You can see that we have paraphrased that question. So when we do the maths, we'll have 24 grams, alright? Just like saying 1 dozen of eggs is equal to 12 eggs. Then 2 dozens of eggs will give us what? 24 eggs. Isn't that simple? So let's have this mental picture for it to make sense. Imagine you are asked to run to the lab and measure out 1 mole of carbon. Since you already know that 1 mole of carbon will weigh 12 grams, you will just measure out 12 grams, isn't it? So in the scenario, you're asked to measure out 2 moles of carbon. You simply measure out 24 grams, which is equivalent to 2 moles. And that's just what is going on in this question. So bear it in mind that questions can come in different forms. Sometimes you need to convert grams to moles and moles back to grams, or Avogadro's number to moles or grams, and also from moles or grams back to Avogadro's number. Alright? Okay, let's look at another simple one. We are asked to calculate the number of atoms in 6 grams of carbon, and we should take carbon to be 12 grams. This question looks straightforward, but there is a caveat. First of all, 6 grams of carbon is not up to 1 mole of carbon, Alright, so because we know that 1 mole of carbon weighs 12 grams, and it was already given in the question when they said C is equal to 12. Alright, so before we continue, we must find out how many moles that are in 6 grams of carbon. Hence, we say 1 mole of carbon contains 12 grams. So how many moles will be in 6 grams? So when we cross and multiply, we'll find the value of x, alright? So when we do the maths there, after the cross multiplication, we'll find the value of x. So at the end of the day, we are going to have 0.5 moles of carbon. Alright, so this is not our final answer, please bear it in mind. It's just the number of moles in 6 grams of carbon. Remember, we are looking for the number of atoms that is equivalent to the Avogadro's number present in 0.5 moles of carbon. Alright, so if 1 mole of carbon normally would contain 6.02 times 10 raised to the power 23 atoms, what will 0.5 mole of carbon contain? So when we do the maths, we are going to have 3.02 times 10 raised to the power 23 atoms. Please make sure you learn the standard form, right? Standard form is a mathematics topic, right? So because examiners have a funny way of recalibrating the standard form, so the answers look very funny sometimes. I'm sure this must have confused a lot of students after doing the right thing. All right. And so guys, we are going to round up this segment with some calculation questions. So if you have any concern or questions, please do well to share it in the comment section. Don't forget to subscribe and turn on the notification bell so you'll be notified whenever I post a new video. Until then, bye.